All right, Advanced Math A, here we go. We've got lesson 7.1.3, creating a flowchart. So a flowchart is where we're going to start making kind of a picture of our decision process. So before we get to that, let's go to part A here on problem 731. How can we prove that these triangles are congruent? Now, based off of the last lesson that we covered, we found out on the first lesson that in order to find that two triangles are congruent, congruent meant that all the sides are congruent and all the angles are congruent. That's a lot. That's like six things. You got three sides and three angles. Well, in the last lesson that we covered, we found out there were two shortcuts we could use. We found out if we had two angles with an included side, meaning a side right in between them, that would be angle side angle. And if we could prove that we had congruent angle, included side, and a congruent angle, that would be enough to prove the two triangles are congruent. The second one was angle side. And these two are basically the same because of the triangle sum theorem. But basically, this one just says two angles and then the non-included side. So looking at what we have here, let's look at this 32-degree angle. So I got a 32-degree angle over here. And what do you know? I've got another 32-degree angle over there. So there we have one angle from each triangle that's congruent. I've got a 75-degree angle up here. Lovely. So I've got a 75-degree angle, and wouldn't you know it, here's another 75-degree angle. So those two angles are congruent. So now I have two angles. Now looking at the sides, side AC has a length of 5.75, so I'll put an angle mark on there, tick mark. And then over here, we got 5.75. Tick mark there. So we now have three things. Now, are these three things one of these two? Is it angle side angle? Well, let's see. If it was angle side angle, the side would have to be between these two angles. So no, it doesn't look like I got angle side angle there. Is it angle side? Let's see. Angle, and then non-included side. Okay, it looks like it, sorry. It looks like it might be that. What we want to double check is that this 5.75 is touching this 32-degree angle. We want to make sure that it's also doing that over here. And 5.75 is touching the 32-degree angle. Okay, so we have angle side. We have two congruent angles and a non-included side. Yes, they're proven congruent because we have angle side. Okay, so that whole process that we did there, where we marked the congruent sides and all that other stuff, we can actually draw a picture of what we've just done. This is called a flowchart. Here we saw that angle A was 32, and you always have to give reasons for why you're saying something, even if it's obvious. The reason why we're saying that is because they gave it to me. They wrote it on the paper. That's what we call given. And then we noticed over here that angle T was also 32. So the measurement of angle T equals 32. How do I know that? They wrote it on the paper. It's given. Okay, so they're both 32. They both have the same measurement. If these are both 32, it means that they're congruent to each other, because that's what congruence means. So the reason is definition of congruence. We know that congruence means their measurements are equal to each other. Right here, we just showed their measurements are equal. They're both 32. So now we can say these are congruent to each other. Okay, moving on. Angle B, that's this one, we said was 75 degrees. Why? Because they told us. It's given. Angle P, 75 degrees, because they told us. Now, these two angles have the same measurement, which means they're congruent to each other, because that's what congruence means. So that's definition of congruence. Everything we write down has to have a reason. All right, next. We knew that AC was 5.75. Why? Because they told me it's given. We know that TO over here is 5.75. Notice that when they're talking about what their distance is that they're equal to, there's no line over it. So TO without a line means the distance from T to O. So that's 5.75. Again, it's given, they told us. Now, because both of these segments have the same length, we can now say the segments are congruent to each other. So AC is congruent to TO. How do I know that? Because that's what congruence means. It means their measurements are equal. Okay, so what do we have now? Well, we have an angle. We have an angle. And we have a side. So what we have is the two triangles are congruent, and the reason is angle side congruence. This is a flowchart. Now in geometry, you have to state everything, even things that seem obvious. What we're doing here is we're building a case. And just like any good lawyer, they are going to walk you through every little bit of evidence, even if it might seem a little bit obvious. Okay, so we're like acting like lawyers to prove these two triangles are congruent. And in order to do that, we're going to walk through every single bit of evidence just in case the people who are listening to our evidence don't really understand. So we're going to explain everything in as much detail as possible so that at the end of these problems, there is no confusion to how we came up with our answer. So we know that they're congruent by angle side because we just proved it. Angle, congruent side, angle side, they're congruent. All right, next one. This flowchart has blanks on it. So they're starting off and they're saying that the measurement of angle C equals 56.5. So here's angle C and it's 56.5. Now notice here, they're going to state that C is congruent to P. So let's go over here to P. What's P? The measurement of angle P over here is 56.5. So I'm going to write it down. Even though it's obvious, I'm going to write it down. So I know that angle C is congruent to angle P. And as I do this, I usually make marks over here on my diagram so that I know what I've done. Okay, next. CA is 12. There's CA. That one. Is there any others that are 12? Yes, this one's 12. So now I'm going to say that PG, the length from P to G, is also 12. Because they told me. So I'm missing that we didn't say that was given, but it is. So CA is 12 because it's given. And now I know that PG is 12 because they told me it's given. So since they're both 12, I can now say that segment CA, notice I'm putting the line now, is congruent to segment PG. And how do I know that? Because it's the definition of congruence. Because if they're equal measurements, the segments are congruent to each other. Okay, last one. Angle G is 102. Where's G at? Here's G. Wait, there's no 102 there. How are they saying that? Because of the triangle of sum theorem. It means that they've done all the work here and did 56.5 plus 22.3. And then plus the measurement of angle G equals 180. So they're saying, hey, I did some work over here. I worked it all out, and I found out the angle G was 101.2 by the triangle sum theorem. See, there's a reason for it. We can't just assume everybody knows what we're doing. We have to tell them why we did it. Okay, was there anything else that was 102? Yeah, there was. This one right here, angle A. So how do I know that angle A is 102? Because they told me. They wrote 102, 101.2. So now I can say that the measurement of angle A is 101.2 degrees because it was given. So now I have just stated two angles that both add up to or both have a measurement of 101.2. So now I can say that angle A is congruent to angle G. Oh, we're missing a reason. The reason is definition of congruence. All right, so what do I have so far? I've got an angle here, I've got a side here, and I've got an angle here. Angle, side, angle, angle, side, angle. The side is included, it's right in between. Angle, side, angle. See, that's what I was proving the whole time. So now I can show that these three things are being used to prove what? The triangles are congruent by angle, side, angle. So now I need to draw my congruent statement. So triangle, remember you can put it in any order. Let's do CAT. So triangle CAT is congruent to triangle. Now which one matches with C? Which one corresponds? C is 56.5 and P is 56.5. So P has to come first. A is 101.2. G is 101.2, so G comes next. And then T has to go with I. So cat is congruent to puggy, whatever. All right. Now, what is the length of PI? PI, I don't know. It doesn't tell me. But look at this. P and I is the first and last letter. C and T are the first and last letter. Those two correspond to each other. Let's look at C and T. C to T is 15. Aha! Therefore, PI has to equal 15. How do I know? Because of the congruent statement. They're corresponding parts in the congruent statement. All right, we are flying. Awesome. Next page. All right, Tanner thinks that these triangles are congruent by angle, side, angle. Good for you, Tanner. Which pairs of angles do you think he's using? Okay, so if he's using angle, side, angle, the side has to be right in between those two angles. Okay, so he's got L and A marked. Those are congruent angles because they got that little tick mark, angle mark. He's got two tick marks there and two tick marks there, okay? And then he's got 90 degrees there and 90 degrees there. Now he also has this side and this side. Okay, so if he's using angle, side, angle, do we know anything about N based on what's already written here? No, we don't have anything marked there. And we don't have B. So he must be using L and R and A and C. Those must be the two that he's using because he knows something about those two angles. Okay, so he's probably using angle L congruent to angle A. He's probably using angle R and angle C. Oops, angle R and angle C. I don't know what letter I was trying to draw there. Okay, and then on top of that, we can probably assume that he's using this segment right in between L and R. So he's also going to probably prove that LR is congruent to AC because that's the segment right in between A and this 90-degree angle C over here. So he's probably not using these two segments. He's just using this segment in between and the two angles on either side of it. AC. All right, so that's probably what he's using. All right, so let's go ahead and do a flow chart. First of all, I'm going to say that angle L is congruent to angle A because they've got tick marks. It's given. So I'm going to say that angle L is congruent to angle A because that's given. They told me it right here with these tick marks. They're the same. Okay, they also told me with the tick marks that LR is congruent to AC. Tick marks, it's given. That's what tick marks mean. It means they're congruent to each other. Now here's the tricky part. This is not a tick mark. This is a right angle mark. So I can't say right now that angle R is congruent to angle C because they didn't tell me that. They just told me they're both 90. Right? So the first thing I'm going to say is the measurement of angle R is 90 degrees. Now I know that because that's the definition of a right angle. And that's what 90 degrees right there means. So this is definition of a right angle. Def of right angle. We're just going to write it like that. And then I also know that the measurement of angle C is 90 degrees. For the same reason, definition of right angle. I really didn't plan out how I'm writing this very well, did I? I apologize. I apologize. All right, so let me zoom this up a little bit. There you go, a little bit better. All right, so now I've said they both have the same measurement. So now I can say they're congruent to each other. So I can say that angle R is congruent to angle C because I said that one's 90 and that one's 90. That's the definition of congruence. I really should have planned out how I'm writing this a little bit better. So what do I have so far? I've got a angle, I've got a side, and now I've got an angle. So I'm going to use this, I'm going to use this, and I'm going to use this, and these three together should be able to say that those two triangles are congruent. I'm going to say that triangle LRN is congruent to triangle ACB. Now, how do I know that? I know because this is angle, side, and angle. It's not proven until you see the congruent sign. So I couldn't prove it here when it was equal to 90. I have to have the congruent sign. We have to give every single little piece of evidence, even the stuff that seems obvious. So the reason for this one is by angle, side, angle congruence. All right, we're almost done. Last problem. Lindsay was solving a congruent triangle problem and drew the flowchart below. So she had three things that were given. Looks like she had an angle, and a side. She said the two triangles were congruent by angle, angle, side. So we're going to draw and label two triangles that we think could represent her problem. Okay, so one of those triangles is ACB. Okay, so triangle. Let's do it in lime green because I'm feeling that way. Okay, so I'm just going to draw a triangle there. That first triangle is going to be A, C, B. All right, now I'm going to draw another triangle because it's a triangle equal to another triangle. All right, close enough, doesn't have to be perfect. So this one's going to be RSQ. RSQ. Now, what was given in her triangle? Well, A was congruent to R in her triangle. So A was congruent to R. That was in her triangle. What else? Angle C and angle S were congruent. So here's C. I'm going to put 2 tick marks on it so I don't confuse it with A. And S, I'm going to put 2 tick marks on it. What else did she know? She knew that BC was congruent to QS. So here's BC, here's QS. That might be what her 2 triangles look like. And that's why she was able to write that the 2 triangles are congruent by angle, angle, side. Because I've got angle, angle, side, angle, angle, side. The side is not included. It's not in between them. Now Marcy, she has a different problem. And this is what her problem looks like. She starts off by knowing the triangles are congruent, and then she draws 3 conclusions from that. How's hers different from Lindsay's flowchart? Well, let's look at what Lindsay's thought process was. She knew that she had 3 congruent sides, and that let her make the conclusion that she had 2 congruent triangles. Marcy knew she had 2 congruent triangles, and since she had congruent triangles, she knew that these angles must match up because A and R are the first 2 letters, so they have to be corresponding. C and S, that's the second letter and the second letter. Those have to be corresponding. And then CB, that's the last 2 letters, and SQ, that's the last 2 letters. Those 2 sides have to be congruent. So how's it different? Lindsay didn't know the triangles were congruent. She was trying to prove it. So Lindsay was trying to prove the triangle's congruent. But Marcy already knew the triangles were congruent, and she was trying to prove that parts of the triangles were congruent, that the angles and the sides that were congruent. So Marcy knew, I misspelled knew, that's bad, knew the triangles were congruent, and was proving corresponding parts were congruent. All right, that's all I got for you, Advanced Math 8. Math hard. Make sure that you don't assume anything. Write down every little detail. Do not skip around. These should flow. That's why they're called flowchart. One thing should flow into the next one. That's what these arrows are doing. You have to be specific. Specificity. All right, I'll see you later. Math hard.